So in this section, we're going to talk about dividing polynomials. We need to talk about dividing numbers first to get an idea of what we're doing. So division, however you were taught to divide. 4 divides 5 one time. 1 times 4 is 4. Subtract. Bring that number down. 4 divides 13 2 times. 4 divides 13 3 times. 3 times 4 is 12. Subtract. That's a 1. Bring the 5 down. And 4 divides 15 3 times. That's a 12. Subtract. That's a 3. So we say we have a remainder of 3. Having a remainder of 3 and a quotient of 133. If I go to the next number up, 675, and I divide that by 5. 5 divides 6 one time, you subtract, bring the subtract and bring the first number down. 5 divides 15 3 times. 3 times 5 is 15, you subtract. And 5 divides 25 5 times. That would be 25, and you subtract, you get a 0. So the difference between those two is what we're going after. If I get a remainder of 0, that means 5 is one of the factors of 675. So the idea here is that I want to factor polynomials to graph them. That's where we're going with this. I want to sketch a graph of a polynomial. If I want to sketch a graph of a polynomial, I need to be able to factor it. And once I factor it, it would look like those. And I could sketch a graph. So, how would I know that a divisor is a factor of the dividend? Well, what I do the division. If I get a remainder of 0, that means I could write 675 as 5 times a number. But if I get a remainder that's not a 0, that means 535 is not divisible by 4, or 4 is not one of the factors of 535. Same idea applies here. If I go to these problems, now we're used to, here we go. If I go in and I do the long division, I'm going to do the long division identically to what I did right there. I am going to take x cubed plus x squared minus 2x plus 1 divided by x plus 2. Oh, by the way, I forgot to mention. It says find the quotient and the remainder. The quotient is 133 and the remainder is 3. Versus here, the quotient is 135 and the remainder is 0. If the remainder is 0, that means that if I take 675, that would be 5 times a number. In this case, it's 5 times 135. Versus here, 535 equals 4 times 133 plus 3. So, the same deal, except you put those in order. X cubed divided by x is x squared. Multiply. X cubed plus 2x squared. You subtract. Whenever you subtract those, subtracting the whole quantity, those cancel out every single time. And if I add those, that's negative x squared minus 2x plus 1. Negative x squared divided by positive x is negative x. Multiply negative x by those two. Negative x squared minus 2x. Subtract. So the quotient is x squared minus x, and the remainder is a 1. That indicates that x plus 2 is not one of the factors of that polynomial. And the same deal here. If I take x to the 4th minus 2x cubed plus 4x minus 1 divided by x squared minus 3x plus 1. X to the 4th divided by x squared is x squared. X squared times this quantity, well, that's going to be x to the 4th minus 3x cubed plus x squared. Subtract. Those cancel out. That is x cubed minus x squared. You could bring them one at a time. I'm going to bring them all down. X cubed divided by x squared is a positive x. Multiply x by this entire quantity. That's x cubed minus 3x squared plus x. That is 2x squared plus 3x minus 3. And if I take 2x squared divided by x squared, that's a plus 2. Multiply the 2 by all of that quantity, that is 2x squared. Okay. Minus 6x plus 2, subtract. So the quotient is x squared plus x plus 2, and the remainder is 9x minus 1. Again, having a remainder other than 0 indicates that this is not a factor. There is also syntactic division, something we're going to use a lot. We prefer syntactic division or long division. There's a catch. To use syntactic division, the divisor must be linear. It can be quadratic. So, if you notice, A and C are the same. So if I use syntactic division, this is how syntactic division works. You write the coefficients of those. So x cubed, x squared, x and a number. And to compensate for the subtraction, if you notice we subtracted every time, we basically take the opposite of this or set this equal to 0. X would be a negative 2. The way it works, you drop the first number, and this is going to be multiplied by anything that goes underneath that line. Negative 2 times 1 is negative 2. Add those, that's a negative 1. Negative 2 times negative 1 is positive 2, that's a 0. And negative 2 times 0 is 0. Add those, that's a 1. This is always the remainder. And this is always 1 power less than what you started. You started with x cubed. So this is x squared minus x plus 0. And you have a remainder of 1. This is the quotient. And there's the remainder. And if you look at there it is. So syntactic division, students seem to not like it in the beginning, but once you get the hang of it, it's pretty quick. How about this problem? Well, again, x to the 4th, x cubed. Do you notice there's no x squared? You must fill in the coefficients, x and the constant. So you must list all in order. If you set this equal to 0, isn't that negative 1/2? And you know, just to make it slightly different, there. So I drop the first number. Negative 1/2 times 4 is negative 2, right? So half of 4 is negative, that's a negative 4. That is a positive 2, that's a 2. That's a negative 1, that's a 5. That is a negative 5/2, that is negative 7/2. So the quotient is, this is 1 power less than that, that is 4x cubed minus 4x squared plus 2x plus 5. And the last number is always the remainder. And again, that indicates for those two that those are not factors. Versus if I get to this problem and I take x to the 4th, that's a 1. There is no x cubed, there is no x squared, there is no x, and there's a constant. And if I set this equal to 0, wherein x equal 1, so the factor is x minus c. And when you test it, you plug the opposite of that. Well, drop the first number, that's a 1. Multiply, that's 1. Add, multiply, that's 1. Add, multiply, that's 1. Add, and if you multiply those, you get a 1. And do you notice you get the remainder of 0? And this is x to the 4th. That means this is a quotient is x cubed plus x squared plus x plus 1. And the remainder is 0. That indicates that I could take x to the 4th minus 1 and write it as x minus 1 times this. And that's a new level of factoring. Well, now let's elaborate on what I've been telling you. Remainder theorem. There's a way of figuring out the remainder without doing the actual work. It says if f of x is divided by x minus c, then the remainder is f of c. So if you count those as f of x, divided by x, the opposite of that. Then if you plug in the opposite of that, you will get the remainder if you plug it in there. And let's play with that, see how that works. So here we go. It's asking, use syntactic division and the remainder theorem to find the remainder. Well, let's see. Syntactic division, if I take 1/3, 3, 5, and a 1. 1/3 of 3 is 1, that's a 6. 1/3 of 6 is a 2, that's a 3. So use syntactic division. Syntactic division, the remainder is 3. And use the remainder theorem. The remainder theorem, take this and plug it in. Find f of 1/3. Isn't that 3 times 1/3 squared is 1/9, plus 5 times 1/3 plus 1? That is 1/3 plus 5/3 plus 1. 1/3 plus 5/3 is 6/3, which is 2, plus 1. That's a 3. And do you notice we got the remainder the same way? How about here? Well, the same deal. If I want to go for syntactic, take 5, 3 for x cubed, x squared, x, and the constant. Drop the first number, multiply, 15, that's a 4, multiply, that's 20. So, no, that's not 20, I lied. That is 4, right? Yeah, 5, oh yeah, that is 20. What am I thinking? And that's 25. 3, 15, that's a 4, 25, and that is what? 125? And my remainder is 75. What happens if I take f of 5? That would be 3 times 5 cubed is 125, minus 11 times 25, plus 5 times 5, minus 50. That is 375 minus 25 times 11, 275, plus 25 minus 50. Well, that gives me 100, plus 25 minus 50, and that's a 75. And do you notice that we did the same thing? So I could find the remainder 2 ways. Either use syntactic division, see if that's what that number is, or I could plug it in. If it's a small number, probably plug it in will be quicker, given the values of C are zeros of this. So given that negative 2 is a 0, that means what? That means if I take f of negative 2, I'll get a 0. Or if I use syntactic division, I'm going to get a remainder of 0. Why is syntactic division more preferred than substitution? Drop the first number, multiply, that's negative 8, add, multiply, that's a 6, that's negative 16, multiply, that's 32, that's a 12, multiply, that's negative 24. Now, why is this preferred over the remainder theorem? Because I will continue on with the second 0 on the leftovers. Oh, what was that? That was negative 3. So this way I'm reducing. Remember, I started with x to the 4th. This is really x cubed. And if I go on, this is going to be x squared. We'll drop the first number. 2 times 4 is 8. That's a 5. 2 times 5 is a 10. That's a negative 6. 2 times negative 6 is negative 12. That's a 0. That means, so far, the zeros are negative 2 and 2. Well, isn't this 4x squared plus 5x minus 6? And if I set that equal to 0, hey, wasn't that the quadratic that we said we're going to need? Two and 2, 3 and 2, 4 minus 6, that's not working. How about 4 How about 2 and 2? And if I go for 3 and 2, did I just do that? I just did that. How about if I go by 4 and 1? And 3 and 2, 2 and 3. 8 minus 3 is 5. That works perfect. And positive and a negative. Right? So that's 4x squared plus 8 minus 3 is 5. Yeah. So I'll get x equal 3/4 and x equal negative 2. So what does that mean? That means I could write this function as x the opposite of that, but there's two of them, x the opposite of that, and this. Whether you write this as x minus 3/4 or you write it as 4x minus 3, it has the same zero. Either way, I can graph them the same way. So these are the zeros. I need to factor to graph. Now, if I still need to sketch a graph, I could sketch a graph really quick. There's nothing to it. X equal 2, 1, 2, x equal negative 2, 1, 2, x equal 3/4. The y-intercept is 24. This behaves like x to the 4th. Multiplicity left to right, negative 2, 0 comes from this. That has to be a parabola. At 3/4, that's a power of 1. And at 2, that's a power of 1. There you go. You can sketch a graph anytime you need. Same deal here. They say, look, we're giving you 2 zeros, find the remaining. Well, remember, I need syntactic division because I need to reduce this. So 2, 21, 78, negative 119, and 60. Drop the first number, that's 2, multiply. 23, multiply. 11, 7, 8, 9, 10, 101. Subtract, that's negative. Okay, something's not add. Oh, that's a negative 21, my mistake. Otherwise, that's not a 0. So negative 21, if you multiply the 2, you get a 2. Subtract, you get negative 19. And what is that? 9 out of 18, that's a 7. And 1 out of 6, 57. And if I subtract those, let me make sure. That was 59. The reason I knew it's wrong because I'm not getting a remainder of 0. So multiply this, that's 59, that's a 0. 5 out of 11 is a 6. Multiply, you get a negative 60. Again, the real importance of me using syntactic division, when I get to the next 0, I'm going to continue the next 0 on the remaining part. I started with x to the 4th. This is 2x cubed minus 21x squared plus 78x minus 119, right? Oh, I'm sorry. This is 2x cubed minus 19x squared plus 59x minus 60. So, if I do that on the remaining part, I reduce it even more. Drop the first number, that's a 6, that's negative 13. That is negative 39. That is 20. That's 60, and that's a 0. So that means my zeros are those two, and 2x squared minus 13x plus 20 equal to 0. If that factors, I'm in good shape. If it doesn't factor, oh well, I'll try something else. Let's go for 2 and 1. Let's go for 4 and 5, 5 and 4. So 10, you're going to add 10 plus 4 is too big. There you go. If you add 8 plus 5, that's 13. They're both negative. So that's 2x minus 5 into x minus 4. So the other zeros would be 5 halves. And 4. Of course, I can sketch a graph of that because they're all multiplicity 1. That's very easy to do. That is each of those is multiplicity 2. This behaves like x to the 4th. Crosses at 60. And since each of those only have multiplicity 1, there it is. They're not asking for the graph of this section, but that's what we're drawing with this. Alright, almost there. Can you go backwards? Find a polynomial of the specified degree. Can you find me a third degree polynomial? Well, yeah. If this is a 0, then x plus 1, remember when we graphed it was always the opposite. X minus 3 and x minus 2. What's a? I need more information to figure out what a is. Unless they tell you the leading coefficient is 1. How about here? Well, f of x equal. A 0 means just x. Minus 1, the opposite, and the opposite of each one of those. You really don't need to multiply this. This is sufficient. And that's pretty much it for this section.